All right. Thank you very much. Hello, everyone. I'm Akshay, as you mentioned. Welcome to this talk on conquering Hadoop and Spark with operational intelligence. So just a little bit about me. I'm a senior software engineer in the data platform team at LinkedIn. I've been in this area for close to 4 years. I'm the engineering lead for Dr. Elephant, and I'm currently working on an operational intelligence platform for Hadoop and Spark, and I'll be talking more about it in this session today. So just to be complete, this is our vision to create economic opportunity for every member of the global workforce, and our mission to connect the world's professionals to make them more productive and successful. So with that, here's the agenda for today's session. I have broadly divided this session into kind of two phases. So in the first phase, we'll look at what problem we are trying to solve and how we are doing it. And in the second phase, we'll look at a bunch of examples and use cases of this system. So diving a little bit into the phase one, we'll look at what issues people face with Hadoop and Spark, how we are trying to approach it, and what are the complications involved in it. We will then look at one major piece of this system, which is the application metrics collection architecture, and then we'll look at the end product, the big picture of how all of these things fit together and solves the problem for us. And in phase two, we'll look at a bunch of debugging and reporting use cases of this. So we will now look at some of the issues that people face with Hadoop and Spark at LinkedIn. These issues are not limited to folks at LinkedIn, but these are some of the common issues people face who use the Hadoop and Spark and part of this ecosystem. So firstly, we have Hadoop and Spark users who find it really hard to debug their jobs. They want to know what is happening with their flow. They want to monitor their flow. They want to understand why their job is running slow, emit certain metrics and visualize them, and so on. And secondly, there are platform developers who would want to track the user behavior. They would want to know how many people are using Hadoop against Spark, how many people are using which APIs in Spark. And they find it hard to debug issues at a cluster level. When something is wrong, they would need to do a lot of root cause analysis to find out what is wrong. And then there are operational experts who would want to set up alerts and monitor the flows. They would want to get notified in advance when a flow is about to fail or miss an SLA so that they can proactive decisions. They would need the ability to do slicing and dicing on certain dimensions. And lastly, there are engineering leads who would want to know how much resources are each team consuming, how much capacity we need to add to the cluster by end of the year, and how to justify with them with metrics. So these are some of the questions, and it's not straightforward to answer them, especially because of the diversity and the complexity of the ecosystem. So we will look at how we are trying to approach this problem and some of the details of those. So here's a very high-level view of the solution. So what we try to do is, first we capture all of the metrics that try to answer these issues, and once that is done, we try to detect outliers in those metrics. And once we have those outliers, we need to have a way to identify the root cause of those anomalies. So this is a very simplistic high-level view of the solution. We will dive into each one of these areas and see what is actually involved in each one of them. So in order to comprehensively answer all of the issues that we saw, the first and foremost thing is that we need to collect a rich set of application metrics in near real time. We would need to collect it from the multiple computation engines that we support, like Hadoop and Spark. Once they are captured, we would need to integrate them with other information like the data lineage, the cluster metadata, and so on. Once all of these metrics are captured, in order to detect anomalies in those metrics, we would require knowledge of various modeling techniques. You would need to know what algorithms you need to run. It requires some in-depth knowledge of the Hadoop and Spark metric system. You wouldn't want to send out anomalies or alerts for every metric, but you would need to have some event-based anomalies to detect an alert only when there is an anomaly in the entire flow rather than the individual metric. And once that an anomaly is detected, in order to identify the root cause of it, you need to have the ability to correlate it with other crucial metrics. you would have the need to integrate events that happen at the company. For example, there was a deployment event, or there was a migration from Hadoop 2.7 to 2.8, or there was some Git commit or some issue, which you can correlate these anomalies and try to identify what could be the likely events that could have led to these anomalies. And lastly, you have this rich set of metrics. You need to have the ability to discover trends in those metrics, do dimensional analysis, and so on. So, this is kind of an interesting and challenging problem. A lot of commercial products have come up in the market that try to solve this problem. And, we at LinkedIn were not able to leverage these products as such due to a couple of reasons. Primarily being, we have a very vast data ecosystem, and with the growing technologies in this system, these products don't adapt well into our ecosystem. Secondly, they surface metrics that are usually powered by the framework itself. So in case of Spark, they surface most of the metrics that are powered by the Spark metric system, which is actually a small subset of the status API metrics that are actually useful. And thirdly, it doesn't give us the required flexibility to extend the systems as per our needs. So let's look into these areas. So first we need to capture all of the metrics that try to help us answer all of these issues. So we will be looking into the application metrics pipeline architecture. In the interest of time, I'll not be going to the details of detecting anomalies and the identification of root cause. But it is, we have achieved it using a platform called Third Eye. It was developed and open sourced by LinkedIn, so you can check it out on GitHub. It's under the Pino project on LinkedIn. But nevertheless, we will look at examples at the end on how all of these things fall together in the bigger picture and how they try to answer the issues that we have. So now let's look into the first one, capturing of all the application level metrics. So here's a high-level architecture of that diagram. So you see three regions here, the blue, the green, and the yellow. The blue region is where we collect metrics from various different sources. We emit them to Kafka, and the green region is where we process those metrics, do aggregations, compute certain derived metrics out of those raw events, and then those processed events are then stored and surfaced to the users. So we'll go into a little bit into the details of each one of these layers. So the first one, the metrics emission, we collect metrics from different sources like the job history server, Spark history server, resource manager, slave nodes, and they are then emitted to Kafka. The kind of metrics we collect are, in case of Hadoop, we collect all of the standard and custom counters. We do that by parsing the job history files in HDFS using Flume and emitting them to Kafka. We also collect JVM metrics by running a profiler or a Java agent with all the slave machines, with the slave containers, and then emit those metrics to Kafka. In case of Spark, we collect all of the status API v1 metrics by simply querying the REST API of Spark history server. We can also collect the JVM metrics using the Spark metric system. And on top of these standard metrics, we do collect certain derived metrics, derived resource and time metrics. For example, we compute the resource consumption of a flow, what's the wastage in that flow, or what was the total duration of the flow, and how much was delay in it. These kind of insights can be obtained from the RM audit logs, which tell us when a container was allocated, for how long it ran, how much memory was allocated, and what containers belong to an application, and so on. So with that, once we have all of those raw events emitted to Kafka, we have a Goblin pipeline that ETLs it to HDFS. So Goblin is a big data integration framework. It deals with ingestion, compliance, replication, and other things. But once we have those events now in Kafka and HDFS, it's a typical Lambda architecture where we have a batch layer and a speed layer. The batch layer does the offline computation, so we have a bunch of Hadoop and Spark jobs that reads these raw metrics, do the aggregation, compute certain derived metrics. And similarly, on the speed layer, we have a stream processing system called Samza. It's another product, open source product of LinkedIn. So what it does, it consumes these raw events from Kafka, processes them in near real time, computes all of those derived metrics as we saw in the batch layer, and then those processed real-time views are then pushed to the storage layer. So one thing that you'll note here is that both the batch layer and the speed layer was essentially trying to do the same thing. So in order to avoid that duplicate kind of logic that was happening, we kind of built a metrics library where we defined all of the metrics and ensured that both the batch layer and the speed layer just calls this metrics library, which is essentially a repository of all the derived metrics. So this way what happens is now the metrics are completely isolated. It becomes easier to monitor the pipeline. It also becomes easier for us to add more metrics and test them out. So with that, we will now look into the storage. Before we look into what kind of a storage we need, it would be good to look into what kind of a query pattern we are looking at. We are essentially looking at an analytics OLAP kind of use case, so where we want to discover patterns and trends in metrics. A typical kind of queries are, do some aggregation on a Spark executor metrics, aggregate it at an application level, and then filter it by which cluster it ran in, which queue, which user, and so on. So these kind of questions kind of answer all of the issues that we saw in the beginning. And Pino was the apt kind of data source that we could use. Pino is a real-time distributed OLAP data store, open source by LinkedIn. People who are not familiar with Pino can relate it to Druid. Pino does support near real-time data, so you can ingest data from both offline and online data sources. It supports a SQL kind of query language. It doesn't support joins, but at the expense of that, it can answer all our OLAP queries within milliseconds and sub-seconds latencies. So apart from all of those technical reasons, we have a huge in-house expertise in Pino, and it is well integrated into LinkedIn's infrastructure. So with Pino, it has a concept of tables. So we have several different tables like application level table, task level table, stage level, and so on. Each one of these tables has metrics corresponding to it. For example, there's an application level table which has all the metrics corresponding to the applications. One kind of challenge here is that because we have arbitrary number of metrics and these metrics keeps evolving, we cannot keep adding metrics as new columns because that will lead to the table exploding. So the kind of schema we resolve to is that we have a fixed set of dimensions and then we have one metric per row, and so we then duplicate the dimensions with every metric changing. So in this way the schema becomes immune to the growing number of metrics, and this is the kind of schema we use for all of the tables. So once we have captured all of the application metrics for Spark and Hadoop, once we are able to configure all of the anomalies, once we have captured all of the events and metadata, that is in essence once we have captured all of the data, what we then need is we need some kind of a curated dashboard. So the Hadoop and Spark experts need to define what are the right set of metrics that you need to look into when you are monitoring a flow. So you define a template where you have all the metrics, how it needs to be compared against which metric, so that once you have this curated kind of a dashboard, a user can just go to this dashboard, plug in his flow name, and he can look into all the right set of metrics that he needs to look into in order to monitor his flow. So that's the kind of thing that you need at the end. You need to have the ability to detect anomalies, and once those anomalies are detected, you should be able to investigate those anomalies and provide feedback to the system. You need to have, in order to do root cause analysis, you need to have slicing and dicing abilities. You need to be able to correlate it with other crucial metrics, other events that happen. And lastly, you have this rich set of metrics, you need to have good visualization on top of it, generate reports, various kind of reports, and send them out. So once you have built all of these components, you need to finally stitch all of these together and provide a coherent experience to the users. So with that, we will now go into the second phase. We will see, we'll again look at these issues and see how the system tries to solve these problems. So this is the kind of a curated dashboard I talked about, where user can go to a dashboard, give his flow name. He sees a bunch of metrics like what is the resource usage against wastage, what is the duration against delay, duration against input records, how many executors were running, how many stages failed, how was the delay distribution across different days of the week, and it gives you a quick summary of all the relevant metrics that you need to look into at a flow. So now let's look at a debugging use case where a user wants to debug a slow job, a job ran slow, and he wants to know why. So in this scenario, he goes to this curated dashboard. It has several different cards or graphs. He starts looking into those graphs. So here you see a graph of duration of that job against the delay. The x-axis is essentially the execution ID, so that corresponds to Azkaban execution ID. Azkaban is a scheduler that we use for running our flows, and those numbers correspond to each execution. And on the y-axis, you see the time. So here you do see that there's a huge spike in the total duration of the job, but when you try to correlate it with the delay metric, you kind of don't see any correlation there. The delay seems to be normal. So you're not in fact getting anything out of this graph here. You just know that the job ran slow because there's a spike in the delay metric. So you then try to correlate it with against how much input records the flow processed. And here, there you go, you find a correlation. So here you see two axes y-axis being plotted. Here you see the time axis as well as the input records the flow processed. So you can now see that when there was a spike in the total duration of the job, at the same point in time, the flow in fact processed a large number of records. And that could likely be it was a backfill execution where it was trying to process a large number of records for the previous week. Let's look at another example where we are debugging a slow job, but in this case, when there was a spike in the total duration of that flow, there was also a spike in the total delay. So you are now trying to have a correlation of the duration against the delay. So now the user knows that the job ran slow because of some delay. He can now debug it further, try to correlate some more metrics. So what I do is I select that specific execution, and this is what it looks like. I have plotted one more metric here. So all the things that you see is on the rightmost side, you see the total duration of the job. The orange is the total delay in it, and the blue one now is a new metric that I added, which is an AM container delay. So AM container delay is essentially the delay in the application master container getting allocated from the time the job was submitted to the cluster. So here you see that out of the total duration of the job, almost 50% of the time was spent just waiting for the application master to be allocated. So this is kind of giving you that insight on why your job ran slow. So at this point in time, the user is confirmed that there's nothing wrong with his job or flow, but it was some external factor due to which his job was slow. He would then come back to the platform team and then report this. Being a part of the platform team, then you would be curious to know why there was this issue, want to identify the root cause of why there was this AM container allocation delay. So what I do is, I try to plot a graph. I select the time duration, I select the same specific flow, I select the granularity, and I do see that there is a spike in the AM container delay. So in fact, there's about 1,000% spike in the AM container delay at that specific moment compared to the baseline, which is the last week. Now I try to correlate this with other metrics, and what I find is that this is another graph. The top one is the same as the previous one where you are seeing a spike in AM container delay, but I have added another correlated metric, which is total resource usage. This is telling us what was the resource utilization of the queue in which that flow ran. So you can see here that at the same moment when there was a spike in the delay, the queue in which that flow ran also was operating at its peak load. So this kind of likely explains that the queue was full and it was not able to allocate more container for the application master to get allocated. But the interesting thing is that the queue was not consistently operating at its peak load, but it was a sudden surge in the load of the queue. So then likely there was something that happened at that moment that caused this spike in the load on the queue. So I try to correlate it further. Resource directly correlates to the number of mappers, reducers, or the executors that are running. So then I try to correlate it against that, and what I find is that the lower one is that you see a spike. There were thousands of executors that were launched at that point in time in that specific queue. And now I know that there were a lot of executors that were running that resulted in a huge utilization of the queue, and then there was no more capacity in the queue for the cluster to allocate the AM. Just a side thing, the horizontal red lines that you see, they are events that happened. Maybe it was a deployment event or some issue that happened on the cluster level that's trying to help us correlate if this issue could be because of that an event. what I then want to know is, this specific executors must have been launched by some user, some flow. I would want to know who that, which that flow is or which that job is. So then I kind of try to do some kind of dimensional analysis on it. So here on the left you see a bunch of dimensions, the application ID, app name, the execution ID of the flow name and so on. And this is trying to tell us, how much positively or negatively a dimension contributed to that metric. So the blue one indicates that that flow or that specific dimension contributed positively towards the metric. And there are also red ones that you don't see here. They say that it contributes negatively to the metric. So in this case, you find a flow there which is contributing 79% positively towards those large number of executors being launched. So now I know which flow it is. I can further do more dimensional analysis. I can find out which job was it, which user triggered the flow, who was the responsible manager, and I can keep on doing this and identify the thing. So once I have done that, I can set up an anomaly so that next time such a thing happens, I do get an alert. So the anomaly was set up, and then I do get an anomaly a few days later. So you see that, the current value of that metric is about 300K, and if you see the week before, the week over 1 week, week over 2 week, 3 week and so on. So in the last 4 weeks it was somewhere between 50K to 70K, and suddenly this week there was 300K, and the system automatically detected it as an anomaly and gave an alert. So then it also tells us, what was the anomaly region, what is the investigation region that you need to look into. It tells what was the time range, what's the granularity. You can then correlate it with other metrics, split them, and then see how this metric is varying. And then finally, if you do think it is an anomaly, you can provide the feedback and say this is an anomaly or this was a false alarm. So with that, we can do a lot of reporting on top of the metrics that you have. You can find out who are the top Spark users on the clusters, how is the Spark workloads distributed across different queues. You can also find out, how was the Spark resource utilization per user, per queue. You can find out offenders on the clusters. So essentially, once you have the rich set of metrics, you have the capability to do anomaly detection and do an RCA, it becomes a really powerful system where you can get limitless insights into what is happening in the grid. So here are some future work. We are planning to add more real-time metrics. Though we do not have as many good use cases for real-time as we had for offline, but there are a bunch of use cases where real-time metrics do make sense. For example, when a flow is running and it's launching a lot of speculative tasks, or a lot of stages are failing and being reattempted. In such cases, you would want to get an alert so that you can investigate it and either proactively take a decision on killing that flow and fixing it, or rerunning it so that it doesn't miss an SLA. There's definitely a lot to improve in the anomaly detection and the root cause analysis areas. Now that we have this rich set of metrics, we can do some machine learning on the metrics, do classify jobs that run on the cluster, and kind of do advanced level of auto tuning on those jobs. And lastly, we are also planning to collect more higher level metrics, metrics that make sense at a flow level and so on. So with that, I wind up this session. Thank you. Could you use the mic, please? I can't hear you from there. Thank you.
Thank you for the presentation. Quick question. Am I correct in assuming that this is an on-premise Hadoop and Spark environment, and
You're right.
you're sharing workloads on clusters?
You're right.
Okay.
So this is an on-premise cluster. And
are you looking at migrating any of these workloads to the cloud, and are you building tooling for that?
No, this tooling doesn't cover anything about that. This is just about how is the workloads on the cluster and how you can detect anomalies, what is happening on the cluster, and identify the root cause of those issues.
Thank you.
Hi.
Yeah.
Thanks for the presentation. Whoa. So my
Welcome.
question for this seems like one part of your monitoring framework at LinkedIn. How does this kind of plug into monitoring everything else that goes on inside the organization as well? Does that make sense?
Right, yeah. So we do have a similar kind of an metrics analytics platform, a unified metrics platform where we do collect business metrics and use the same kind of technologies like Pino for doing the analytics. We have an own internal visualization tool called Raptor for doing all of these things. And there's a tool called Third Eye, like I said, which can do root cause analysis and anomaly detection across all of the business metrics that we have. And we are just leveraging the same system for doing the grid metrics.
Hi.
Yeah.
Thanks for the session. Now, I had a quick question. Is there a performance overhead in the metrics accumulation for each job? Like, do you see anything like an overhead?
Yeah. So in case of Hadoop, we were collecting metrics by parsing the job history logs. So from that perspective, there was no much issue there. But in case of Spark, we did see issues when we were talking, when we were connecting to the Spark history server. There's another session later today at 4:20 given by Edwin and Ye that talks more about the challenges of getting metrics from Spark history server. I believe it's metrics-driven tuning of Apache Spark at scale. And apart from that, in order to collect those JVM metrics, we had to launch these Java agents on every slave machines. We did face some issues while connecting to Kafka because there were so many containers being launched, but they were not a significant impact. All right, I guess, thank you.